Let us talk about all important Bolzano-weirstrass theorem. This is a very crucial proof which establishes that if we have a sequence which is bounded, it must have a convergent subsequence which converges to a limit point which is involved in the closed and bounded interval which contains all these xn. So let us again try to understand what is Bolzano-weirstrass theorem. It states that any sequence which is bounded has a convergent subsequence, and this subsequence converges to a point in this sequence only. Okay? We should remember in this regard that a very special sequence, this is bounded but not convergent. It has two subsequences which converges to two different limits, one minus 1 and one plus 1. There are many such examples. Bolzano-weirstrass theorem just states that if a sequence is bounded, it must have a convergent subsequence which converges to a limit point contained in this interval. Now let us try to prove it with the help of nested interval property. We assume that this interval a to b, which contains the bounded sequence xn, is divided into two equal parts. One is I1 and another is I1 prime. The mother interval I, which is closed and bounded, is divided into two equal parts. So the length of each of them is b minus a by 2. Now, as per assumption, either 1 or I1 prime contains infinite number of xn. We take that particular part which contains infinite number of this sequence and then divide it again equally to two parts, I2 and I2 prime. So this interval of length b minus a by 2 is again divided, resulting in two different intervals of each of length b minus a by 2 square, and we move on with this process to reach at the kth stage to the interval ik of length b minus a by 2 to the power k, which contains infinite element of xn such that n is greater than or equal to k. Okay? Or we may take it and strictly greater than k. The basic idea is that starting from this mother interval closed and bounded AB, we start dividing them in equal parts and choose only that part of interval which contains infinite number of elements of this xn. So after kth stage we reach to a part of this interval which has length b minus a by 2k, and obviously this length of ik tends to 0 as k is large, isn't it so? Because it is 2 to the power k. So whenever k is 10, it is 2 to the power 10, which is a fairly large number, and b minus a is a length which is fixed. So b minus a by 2 to the power k will be very, very small. And all these intervals are nested because I1 prime is contained in I, I2 prime is contained in I1 prime, and Ik prime is contained in Ik minus 1 prime. So this is a nested interval. And we know that all these intervals will converge to a specific unique limit which is contained in this interval. And so you can always have a sequence xn k which converges to this limit point which is contained in this interval, and that is precisely what is Bolzano-Weierstrass theorem, that whenever we have a bounded set or a bounded set of real values, it must have a subsequence which is convergent, and that subsequence is the points in these nested intervals.